Hey guys, Mr. Backerberg here. In this video we're going to look at solving absolute value inequalities. The process that we use to solve an absolute value inequality depends on what type of inequality is that we're dealing with. If we're dealing with something where the absolute value of u is less than a, then that means that u must be on the interval between negative a and positive a. So what we can do with this information is we can actually take this absolute value inequality and convert it into a double-sided inequality, which will help us solve this later on. So first what we do is we just write out our inequality with the absolute value symbols dropped. So we're just going to say that u is less than a. But then on the opposite side, we're going to throw negative a on there, and negative a has to be less than u. So we can use this double-sided inequality to help us solve this absolute value inequality if it's got that less than symbol in there. If we're dealing with something where the absolute value of u is greater than a, then u is in one of two intervals, either between negative infinity and negative a, or it could be in the interval from a to positive infinity. So here what we're going to do, if we have an inequality with a greater than symbol, we're actually going to split this into two separate inequalities. The first one is going to look almost exactly like the original one, just with the absolute value symbols dropped. So that's going to look like u is greater than a. But for the other inequality, we're going to use negative a, but if we flip the a to a negative a, then we also need to flip around the inequality symbol. So here we're going to come up with two separate inequalities that we will have to solve. So in this first example, we're going to look at the absolute value of x minus 4 is less than 8. What we should notice here is that we've got a less than symbol, and our rule said if we've got a less than symbol, then we're going to take this absolute value inequality and rewrite it as a double-sided inequality. So first thing we do is just drop the absolute value symbol. So we've got x minus 4 is less than 8. But then on the opposite side, on the left-hand side, we're going to throw negative 8 in there and another less than symbol. Now our goal here is to solve to try to get x alone, and right now we've got that minus 4 in there. So in order to get rid of the minus 4, we're going to have to add 4, but when we do that, we have to do it on both sides of our inequality. So on the left-hand side, negative 8 plus 4 is negative 4. Then in the middle, we've got just our x left over, and on the right-hand side, 8 plus 4 is 12. So our x value is somewhere between negative 4 and positive 12. Now we can take this answer and write it in interval notation. So we're going from negative 4 to 12. Neither one of these inequality symbols has the equals to line underneath it, so that means that our endpoints are not included. So writing this in interval notation, those would get parentheses around them. In this example, we've got the absolute value of 3x minus 2 is greater than or equal to 5. So this inequality has a greater than in there with that absolute value. So our rule said that if we have a greater than symbol in there, we need to take this absolute value inequality and split it up into two separate inequalities that we're going to solve individually. So the first inequality is going to look almost exactly the same, except we're dropping the absolute value. So we get 3x minus 2 is greater than or equal to 5. For the other inequality, what we're going to do is we're still going to take that 3x minus 2, but we're going to switch the 5 to a negative 5. And when we do that, we have to flip around our inequality symbol. So instead of being a greater than or equal to, flipping it around, it's going to be a less than or equal to. And now we're going to go through and solve each one. So I'm going to start with this inequality in the blue here. So first thing I'm going to do is take that minus 2 and add 2 to each side. So then we'll get 3x is less than or equal to negative 3. And then we're going to divide by 3 in here. So we're going to get x values that are less than or equal to negative 1. Now if we go back over to our other inequality and work on solving that one, again I'm going to add the 2 first to get rid of that. So we get 3x is greater than or equal to 7. Divide by the 3 on both sides, and we're going to get x values that are greater than or equal to 7/3. So the answers are the x values that are less than or equal to negative 1, or the x values that are greater than or equal to 7/3. Now we can take this and write it out in interval notation. So for this first inequality, where we've got x values that are less than or equal to -1, there's no smallest value there, so we're going to start at -infinity, and infinity always gets a parenthesis around it. Then we're going up until we hit -1, so that's our stopping point. We do have the equals to line underneath our inequality, so that means -1 is included, so it gets a square bracket around it. We're going to have two separate intervals here, so we're going to use our union symbol between them. And then our other interval looks like we've got x values that are greater than or equal to 7/3. So we're going to start at 7/3, including the endpoint, because we've got the equals to line underneath our inequality. And there's no stopping point here. We're looking at all the x values that are bigger than 7/3. So that's running out to positive infinity. And again, infinity always gets a parenthesis around it. That's going to be it for this video. Thanks for watching.